Hello Senior 1, welcome with our fifth session in Unit 1, Algebra. So we will talk about the sign of a function. We have three types of the function. We have that the function maybe become positive function or become negative function or become equal 0. So we have here function is positive function if it's greater than 0, and we have the function equals 0 if it's f of x equals 0, and we have the function is negative if it's smaller than 0. Okay, now let's talk about the constant function. The constant function is a function in form of f of x equal c or f of x equal negative c. So that means the sign of the function is according to the sign of the number of the function. So if I have f of x is equal c, so c is positive, that means the function f of x is positive. An example for that, f of x equal 4 is a positive function because we have here 4, not negative 4. And we have f of x equal negative c, so here we have the number is negative. So in this case the function is also negative, just like f of x equal negative 3. Now let's talk about the linear function. The linear function is a function in form of f of x equal bx plus c, and we have the interval x greater than negative c over b. In this interval, the sign of the function is always b, just like the sign of b. So f of x sign is just like the sign of b. So we have an example, f of x equal 1 minus half x, and we need to determine the sign of the function. So here b is negative, and we need to get the value of negative c over b, and negative c is negative 1 and b is negative half, so in this case it will be 2. So we will talk about the interval x greater than 2. In this interval the sign of the function takes the sign of b, and sign of b negative, so the function will be also negative. At the interval x smaller than 2, the sign of the function become inverse of the sign of b, so the f of x will be positive. And at x equals 0, the function f of x is equal 0. Now let's talk about the third kind of function, which is called quadratic function, and it always be in form of f of x equal ax power 2 plus bx plus c, and we have two roots for this function, which is L and M are two roots of this function. That means L and M, if it's substituted from x, so we will get f of x equal 0. So we have here the controller here for the discriminant. So we have three cases for the discriminant. If I have the discriminant is greater than 0 or equal 0 or smaller than 0. Now let's take the first case. If I have the discriminant is greater than 0, in this case we have f of x takes the sign of a, in the value, in all value in real number except the interval L from L to M. So f of x takes the sign of a, just like a, adds the value all real number except the small interval from L to M. And f of x takes the inverse sign of a at the interval, the open interval L and M, because it's open, because if I take L and M, these two values are the root, and the root make f of x equal 0. So now let's take the discriminant is equal 0. In this case, we will get that the two roots are equal. And in this case, if I take if I take x equal L or M, in this case the function will equal 0 at x equal L or M. And f of x takes the sign of a at the interval all real number except that value which is called the root. Now let's take the third case, which is the discriminant is smaller than 0, and in this case the function f of x takes the sign of a. Now let's take an example for that. Now if I have f of x equal x power 2 minus 5x plus 6, now we have to factorize this form, so it will be x minus 2 and x minus 3 equals 0, and I equate this with 0 to get the two roots L and M. So L will equal 2 and M equals 3. Now let's get the discriminant. Now to get the discriminant, we have to get the value of A and B and C, and we have A equal 1 and B is the coefficient of x equal -5 and C is the absolute value is 6. Now by substituting from A and B and C, we will get that the value of the discriminant equal 1, which is greater than 0, and that's mean f of x is positive at all real number except from 2 to 3. And number 2, the function f of x is negative at the interval from 2 to 3 except 2 and 3. I made it open because 2 and 3, if I substitute with 2 and 3, it will make f of x equal 0. And thanks for listening, and this is our session today. Thank you.